Good evening, class. We are looking at Module 2, Chapters 3 and 4. Chapter 3 is Functions, and Chapter 4, Linear Functions. And here's Chapter 3, Functions. So let's remind everybody of some of the definitions we have seen. It's about Chapter 3. So dependent and independent variables. For an equation in variables x and y, if the value of y depends on the value of x, then y is the dependent variable and x is the independent variable. In other words, when you have a pair, the first one is the independent variable, the second one depends on the first. This represents the domain range, and we'll discuss it in a moment. A relation is defined as a set of ordered pairs. Domain, the set of all input values or x values or independent variable for a relation, basically the first variable. Range, the set of all output values, y values, dependent variable for a relation, in other words, the second variable. A function is defined as a relation in which each element in the domain corresponds to exactly one element in the range, meaning the x coordinate does not repeat. And therefore, we can test it with a vertical line test. If a vertical line can be drawn so that it intersects a graph at more than one point, then the graph doesn't represent a function. If not, then the graph represents a function. So let's look at these graphs. If this is a graph, whatever it covers along the x-axis is the domain. Whatever it covers along the y-axis is the range. Same thing here. If you look at this, there's the domain, which actually means all real numbers, and range along the y-axis. Both of them are all real numbers, but this one, the domain is limited from here to here, let's say A to B, and then range is limited from over here to here, C to D. A function is one-to-one if each element in the range corresponds to exactly one element in the domain. In other words, a function x coordinate can't repeat. A one-to-one function, now the y coordinate cannot repeat either. And therefore, we check it with a horizontal line test. If a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not a one-to-one function. And I put this equation here to remind you of what's called DQ, difference quotient. Difference quotient, which is simply put is rise over run or average rate of change of y with respect to x, or simply the slope, f of x plus h minus f of x over h. Obviously, h or the denominator can't be 0. All right. Let's start with some simple example. We want to find the domain of each function. Whenever you have a rational expression, all you have to do is set the denominator equal to 0 and exclude that. So 2x minus 1 equal to 0 gives rise to x equals 1/2. So we can't have that because it makes the denominator 0. So to write that, there are two ways to write it. You can write x is not equal to 1/2. This is one way to write it, and that's okay. But this is a more proper way known as an interval notation. When you're dealing with a root function, if the index is odd, there is no restriction. If it's even, as you can see, there is no index. That means the index is 2. When it's even, what's underneath must be greater than or equal to 0. And you solve that. So simply put, you move this to the other side, becomes -4 and divide by 5. And again, this is one way to write that. but this is the interval format. And the last one, any polynomial, there is no restriction. The domain would be all real numbers. This is a polynomial of degree 2, but any polynomial, the domain would be all real numbers. So the reason it's you can say it's a quadratic function, QF, quadratic function, or you can say a polynomial of degree 2. That means the same thing. As I mentioned, when you're dealing with the cube, when you're dealing with the root function, you look at the index. In this case, the cube root. When the index is odd, no restriction, all real numbers. So simply put, the reason why the index is odd, an odd number. It's an odd number. Third root, fifth root makes no difference. Any rational function, for that matter, any fractional format, you set the denominator equal to 0 and you exclude that. So x squared minus 1 is 0. That means x squared is 1 and x is plus minus 1. So those two numbers are out. Everything else is fine. So you could write it in this format, but a better format would be an interval format. So for that reason, we're going to write this in an interval format. So negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. This would be the more proper way. Please understand, parentheses means we are excluding the endpoints negative 1 and 1. F of x equals 2/3 x plus 7. The domain is all real numbers. Why is that? Again, you can say it's polynomial of degree 1 or it's just a linear function. It's a linear function. Determine if the graph represents a function, a one-to-one function, and find the domain and range of each using interval notation. Remember, if the x-coordinate doesn't repeat, if the function can pass the VLT, vertical line test, it becomes a function. And if it passes the HLT, horizontal line test, it becomes a one-to-one function. And this is both. So it's a function and also it's a one-to-one function. Domain would go from, see, it covers this point, discover this point from 2 to 8. Is 2 included? No. Why not? Because there's a hole here. Is 8 included? Yes. So if I were to, graph this, I would go with this one, everything in between. So from 2 to 8, 2 is not included, 8 is included. Along the y-axis, let me use a different color. Here it's included. Here's is not. Anything in between, 6 and 8. 6 is yes, 8 is no, and we use bracket to represent the endpoint that is included, parentheses, where it's not included. Let's look at this function. Can it pass a vertical line test? Yes. Is it a function? Yes. Can it pass a horizontal line? No. Right here. Okay, if you pick any horizontal line, this one and this one have the same. Let's just draw something. If I draw any horizontal line, you see that there are two points, and therefore it can't be a one-to-one function. So yes, it's a function. No, it's not a one-to-one function. What about the domain? Along the x-axis, if you look at this graph, this is the endpoint here. It covers it here. This is the endpoint here. It covers from here to here. Is -3 included? Yes. Is +2 included? No. From -3 to 2. -3 to 2. What about the range? This one covers -5 all the way. This one covers 4. So the range covers this point all the way to this point and anywhere in between. And the endpoints are both included. Part C, is this a function? No. It fails the VLT. Is it a one-to-one function? No. It fails the HLT. So it fails the vertical line test, fails VLT or the vertical line test. This one fails HLT or horizontal line test. So what is the domain? The furthest point here is going to cover here, which is -4, all the way to this point, which gets to 0. So this is the domain of the function. In other words, whatever it covers along the x-axis from -4 to 0. What about the range? The bottom will cover 0 and the top will cover 4. So from here to here along the y-axis is covered. So 0 to 4. Pretty straightforward. F of x is given as 2x plus 1. We want to find and simplify this difference quotient f of x plus h minus f of x. So let's remind everyone of a couple of things. Number one, rates of change. The difference quotient, or delta y over delta x, is f of x sub 2 minus f of x sub 1 over x sub 2 minus 1, is called the average rate of change of y, or f of x with respect to x, over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line PQ. So if you happen to have a curve and you pick 2 points and connect them, the slope of this line is known as a difference quotient. Now, this line is known as a secant line. Okay, it's called a secant line. Now, how do you find that? There are different ways of approaching it. If you go with x sub 2 and x sub 1, we have this formula. First of all, you remember it's y sub 2 minus y sub 1. Just remind you, of course, everybody knows. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So how do you write that? Well, if you go with this writing x sub 1 and f of x sub 1, and this writing x sub 2 and f of x sub 2, we get the first one. if we call this point A, then this is f of A. If we call this B, just write that. So if I call this point B and f of, okay, in other words, the distance is B, okay? The distance from 0, this is B, if you call this B, okay? And so with that being the case, we get to this formula, f of B minus f of A over B minus. If you have the first pair as A and f of A and the second one as A plus H, it becomes f of A plus H is the last one, okay? If instead of A plus H, if we call this X, we get this formula. All of them refer to the same thing, everybody, okay? All of them refer to the same thing. Rise over run. All right. Let's do this. We want to find f of x plus h minus f of x over h. So all you have to do, put it in this formula. This part is simply 2x plus 1. This is h. What is f of x plus h? 2 times x plus h plus 1. So I hope you realize this is 2 times x plus h plus 1. Minus f of x itself over h. Now we are going to simplify the numerator as follows. This is 2x plus 2h plus 1 minus 2x minus 1. 2x and negative 2x cancel each other. Positive 1 and negative 1 cancel each other. We get 2h over h, which simplifies to 2. All right, we want to find f of g of 2. So let's remind everybody of composite functions and operational functions. F of f plus minus g of x, that means f of x plus minus g of x. That means the sum and difference functions. F g of x, that means f of x times g of x. F over g of x, that means f of x over g of x. Needless to say, as always, the denominator can't be 0. Those are operations. Also, we have a composite function. F of g by definition means f of g of x. G of f of x means g of f of x. And so if this is f, and this is g, this is the domain of f, okay? So we have FOG, domain of FOG, range of FOG. This one is the G function. So X maps into the G function, and X maps to the F function here, and FOG maps the G into F function, and that's the relationship among their domain and range. It becomes clear as we go over that. So f of g of 2. So the very first thing we need to do is to calculate g of 2. So here's g of x. We are going to plug in 2. So 3 times 2 minus 5. That's obviously 6 minus 5 equals 1. Let's just write at top of it. Okay. So we want f of 1. So plug in 1 here. This is 1 times 2 is 2, 2 and 1 is 3. So this is 1, this makes it 2, and 1, they add up to 3. What about f o g of x? That means f of g of x. That means replace the x in the function f with the function g. So replace the x with the g function. So you can actually write put the g and then replace the g with whatever g represents, which happen to be 3x minus 5. Now, we are going to raise this to the second power. This is 9x squared, then 2 times 3 times 5 makes it 30, so minus 30x, and then plus 25. We distribute the 2, we get 18x squared minus 60x plus 50. All we have to do, add these two pieces, and we are done. All right, we are going to look at GOF now. GOF by definition means G of f of x. So into this function goes f, meaning replace the x with the function f of x. You can even put f here, 3 times f minus 5, and replace the f. So this is 6x squared plus 3, positive 3, negative 5. They add up to negative 2, and we are done. GOG. That means the x coordinate of the g of x gets replaced by the entire g. So replace the x with 3x minus 5. So 9x minus 15, these two add up to negative 20. The final answer, 9x minus 20. Let's find FOF of negative 2, which means we're going to rewrite this as f of negative 2, which means first we have to find f of negative 2. So what is f of negative 2? Replace the x with negative 2. F of negative 2. So 2 times negative 2 quantity squared plus 1. This is positive 4 times 2 makes it 8. With 1 makes it 9. And we're done. Now we go back to the question, and what was the question is asking? F of minus 2 is asking for f of 9. So into this function goes 9. As you know, 9 squared is 81. 2 times that is 162, and 1 becomes 163. Determine if the functions f of x and g of x are odd or even. So what was the definition of an even function? F of minus x is f of x. Odd function, f of minus x is minus f of x. So I remind you, an even function, f of minus x is f of x, that's been symmetric with respect to the y-axis odd function f of minus x is minus f of x, that means symmetric with, with respect to the origin. WRT, with respect to. So all you have to do, evaluate f of minus x and g of minus x to see what happens. So let's start with f of minus x. So replace the x with negative x. Nothing changes because this is x squared. So it's identical to f of x. That means f of x is an even function. We do the same thing to the g of x. That means we are going to find g of negative x. And if you replace the x with minus x, this becomes negative 3x minus 5, which is equal to the original one g of x? No. Is it equal to its opposite, minus g of x? No. So it's neither even nor odd. So we just simply put g of x is neither. Find the average rate of change of each function on the given interval. So in this case, f of x is 3x. We are given the interval of negative 1 to 1. And I remind you of the definition of average rate of change that we discussed. So in this case, basically, if we stick with this one, f of x sub 2 minus f of x sub 1 over x sub 2 minus sub 1, this is your x sub 1 in essence. This is like x sub 1, and this is like x sub 2. You can use this formula, or you can say this is A, this is B, and use this formula. It doesn't matter. The bottom line is f of 1 minus f of negative 1 over 1 minus negative 1. So, what is f of 1? 3 times 1 over 3. What is f of negative 1? 3 times negative 1. So the numerator is 3 minus 3 times negative 1. The bottom is 1 minus negative 1 over 1 plus. So what we end up with is 3 plus 3, 6 over 2, or 3. What about this one? From 4 to A? Well, basically it's f of A minus f of 4 over A minus 4. Understanding the concept. So we are going to replace the x with A in this function. I'm sorry, in this function. So this becomes 2 times A minus 9. And then replace it with 4, 2 times 4 minus 9, and the bottom doesn't change. So we have 8 here minus 9. So the numerator is 2A minus 9 minus 1. So it becomes plus 1. Minus 1. Please understand, 8 minus 1, 8 minus 9 is negative 1. So let me just put the negative 1 up here. So this negative makes it positive. The numerator is 2A minus 8. We can factor the 2 out, and okay, so this is 2 class, okay. Let me just rewrite this. This is a minus 4, and these two cancel each other, and we get 2. Okay. All right. What about this case? We are going to calculate f of 2 plus h minus f of 2 over 2 plus h minus 2. So what is f of 2 plus h? 3 times 2 plus h plus 4 minus, what is f of 2? 3 times 2 plus 4. Denominator is only h. Let's distribute and simplify. Okay. As you can see, 6 plus 4 cancels out negative 10. The numerator is only 3h. The final answer is 3. All right. Graphing techniques, transformation. Let's remind everybody how it's done. So you have the basic function y equals f of x. And we are assuming there is a number c, and we take that number to be positive. So f of x plus c is the same function shifted up by c units. F of x minus c is the same function coming down by c units. F of x minus c is the same function shifted to the right by c units. And f of x plus c is the same function shifted to the left. So that's the shape doesn't change, it just moves, okay? Now going back to the original function again is y equals f of x. And remember, c is going to be a positive, and in this case we are assuming it's larger than 1. Like 2, 3, 4, 5, 1.5. So if we multiply the function by c times f of x, it multiplies its y coordinate and it brings it up by a factor of c. It has a stretching in the vertical direction. Since c is a positive value, if we have 1 over c, that means, a number less than 1, it shrinks it by that much in a vertical direction. If we multiply, if f of c of x, f of cx, then it's going to shrink it by a factor of c along the horizontal direction. If you divide it by c, it's going to stretch it. It works the other way around. If you have a negative in front of a function, so that means f of x, you put it in front of a function, it negates the y coordinate and it flips it over with respect to the x-axis. But if you put the negative inside the parentheses f of minus x, it reflects it with respect to the y-axis. So these are some transformation. we are going to use those techniques. The following function, this graph, this function, was graphed by applying transformation to a toolkit function. When we say toolkit function, sometimes they call it essential function, sometimes they call it basic functions, sometimes they call it basic algebraic functions. We want to write the equation of a function that matches the graph. And so I want to remind everybody how each basic function looks like, and we are supposed to know them. So a constant function f of x equals b looks like that. It's assuming b is positive with 0b representing the y-intercept. You have a horizontal. F of x equals x is a line that goes through the origin. Y or f of x equals x squared, the parabola opens up, basic. F of x equals x cubed, a cube function looks like that. F of x equals square root of x, a root function with the index even, square root more specifically looks like that, and a cube root looks like that. So we should know that. In this case, you may recognize it's an absolute value function, and an absolute value function looks like a V shape. V shape. So the vertex is located at 0, 0. And the formula is y or f of x equals absolute value of x. So that's the basic we start with. So what transformation takes place? We want to find the equation. So one easy way is to locate easy points. Number one, the vertex has coordinates 3, -2. And the formula for general formula of an absolute value function is the same as a quadratic function. If you recall, it was a times x minus h quantity squared plus k. In this case, is a times x minus h in an absolute value plus k. So it looks like that. So if we call this, if we have h and k as the vertex, if you recall, this is what we wrote for a parabola. For a general form of an absolute value function would be a times the absolute value of x minus h plus k. Okay, that would be the formula. And so that's what it is. Everything is fine except a is missing. So all you have to do, pinpoint a point and plug it. So there are a couple of easy points. The intersects, you can see this is 1, 0, this is 0, 1. All you have to do, use one of it. For example, if I use this one instead of y, I'm going to put 1. Instead of x, I'm going to put 0. If I use this one, instead of y, I'm going to put 0. Instead of x, I'm going to put 1. So any of them is fine. So for example, if I use the first one, x is replaced by 1, y is replaced by 0. As you can see, this is -2. And the absolute value of -2 is +2. So it's 2a minus 2 equals 0. And obviously, a becomes 1. And that's your final answer. Now, I highly recommend you check that. How do you check it? We used the first point to find a. Now we're going to use the second point to check. If you replace the x with 0, you get absolute value of -3, which is 3 minus 2 is 1. Yes, it works. So always check your work to be on the safe side. We are looking at the same type of question, the following function was graphed by applying transformation to a toolkit function, essential function, a basic function, where the basic functions are what we mentioned in the previous page, f of x equals x squared, square root of x, so on and so forth, etc. Write the equation of a function that matches each graph. Okay, and so let's do that. I hope you recognize it's a root function, it's a square root function, so there has been some transformation, we're going to take it from there. So y equals square root of x has the intercept of 0, 0. However, this guy has an intercept of -3, -1. So the intercept, by the way, it's both x and y intercept, has been shifted to this new location, -3, -1. So the shift is therefore 3 units to the left. That means it becomes x plus 3. 1 unit down, that means -1. So we have square root of x. Inside is plus 3. Outside is -1. Now, since we are not too sure if this hasn't been stretched, we want to put an a in front because this a may or may not be 1. We don't know yet. We have to figure it out. And all you have to do, pick a pair and check it out. Now, are you going to use the intercept that was moved? No, you already used the intercept. So what are you using? Any other point. Always use the easy point. Notice the x-intercept has a location -2, 0. So replace the x with -2 and y must be 0, find a. Now this is 1, square root of 1 comes as 1. So a minus 1 is 0, therefore a must be 1, and here's your function. A quick recap, we noticed the graph looks like some sort of a square root of x that has moved, perhaps even other changes, we don't know. So we start with the basic function and we notice the vertex, the intercept is located at 0, 0 originally, has moved, and according to that move we write this equation. And the reason we put the a in front, because if there has been a stretch, we don't know that. You have to make sure there is no stretch, or if there is some, we find it. So we have the same situation. In this case, this is the graph. You want to find the equation of a graph, and we know it has got to do with this quadratic function. We remember here's the shape, here's the graph, and the equation is y equals x squared, and the vertex is located at 0, 0 originally, but now it has shifted to a new position which has coordinates -1, +2. And as you recall, it's y equals a times x minus h quantity squared plus k. We are going to replace the h with -1, makes this +1, and this one is 2. So this is the formula, and what is missing is a. And how do we find that? As long as we have one more point, you always want to go with easy point. This point is clearly having coordinates 0, 1. Replace the x with 0 and y with 1. Easy point is 0, 1. This is 1, square root is 1, so this whole thing is 1, and it becomes a plus 2 equals 1. So a must be negative 1. So now replace the a, and it works. By the way, when you're done, if you want to check, pick some other easy points and check it. For example, this seems to be at 1, negative 2. Okay, you can try that. In fact, if you put 1, 1 and 1 is 2, squared is 4, with this becomes minus 1 and 2 is 2. So you can check it with this point, for example. Again, let me just, so you should always check your work to be on the safe side. So check to make sure this pair, which has coordinates 1, negative 2, works, and it does. So always check. Find the equation of a function that is finally graphed after the following transformations are applied. The graph of y equals x squared. The first one, we're going to shift it right by 3 units. So we're going to write x minus 3 quantity squared. So f of x is x minus 3 quantity squared. Now, to this, we apply the next step. Reflect about the x-axis. So we put a negative sign in front of it. Shift down by 2 units. So bring it down by 2 units. So minus 2. And that's the final answer.